out to everyone. This month we've got Zerina and we've got Andrew Nelson, who are both going to talk a little bit about TV whitespace. Zerina will dig a little bit deeper into last month's discussion and focus more on the narrowband TV whitespace options, and then we'll have Andrew, who's always fantastic. We'll share some of the FarmBeats work that he's been doing out on his farm, and then I think he's also going to talk a little bit about TV whitespace, but he can let us know once he joins. I don't see him online yet, so hopefully he'll be here soon. And then just a quick reminder, we still have Phoebe taking some notes for her project. So if you have questions about that project, I put a link in the chat, and you can also reach out to Phoebe or myself or Elizabeth if you have any questions. And then one other thing I wanted to note was just a quick thank you to everyone in the community. We've been using the FarmBeats user community for participation, collaboration, and just learning about the different projects that everyone is doing. We've had our community meeting since May, and you can see we initially started with just 3 universities and less than a dozen participants, and now this month we've got lots more groups and people joining, lots of people watching the recordings online. So I just wanted to say thank you to all of you for the help that you've given to make this community grow into what we've got now. So we've got our Teams channel, the YouTube site, GitHub, lots of different resources. So if you have any questions, there's always a place for you to reach out and find answers. And you can reach out to Elizabeth or myself anytime with questions. So thank you very much.
And welcome to all the new folks that have joined us since we started this about a year ago, 9 months ago. So welcome. And just for any of you tuned in, if you don't mind muting unless you're speaking, that would be awesome.
All right, so I think we'll go ahead and kick things off with Zerina. And if you have questions, you can, I think she'll be open to taking questions, or you can just put your questions in the chat.
Yeah, hi everyone. I'm just going to share my screen real quick. Hopefully everyone can see that. So today I'm going to be talking about the TV whitespace IoT radios that we've been developing at Microsoft, and I'm sure a lot of you have already heard a bit about it. And yeah, I'm happy to answer any questions along the way, so feel free to interrupt me during the presentation. And also Tushar is on the call, and he's been, really crucial in all of this development. So he can definitely help answer any really specific details if anyone has questions. So I'm just going to get started. So to just give you a little overview and general features, this radio we developed, it operates in the upper VHF, UHF, 800 megahertz and 900 megahertz band, and it uses a new protocol that we developed that's built on top of LoRaWAN. So at a high level, when our system's provided with a list of available channels, then enabled narrowband TV whitespace IoT devices can use the spectrum without causing interference towards, the TV receivers and occupied TV channels or other protected devices or services. And so the development of these radios is really, really exciting because there's a lot of performance benefits from being able to operate in the TV white spaces. And in this case, particularly for IoT applications. So here what you're seeing are just some general features from the radio. It operates at very low power, which is really important for IoT deployments, and it has a lot of programmable features such as the RF output power and the different modulation parameters such as spreading factor and bandwidth, similar to LoRa, which define your data rate and how robust your communication will be. And some other things like the communication range is greater than 10 miles. We use USB and UART for data control. And so here are also some of the specs from the radio with a few of them being preliminary. And I can also share these slides afterward if anyone wants to have this info to look at later, but this just highlights things like transmit power, receiver sensitivity, and just power consumption of the device. So for the rest of my presentation, I'm just going to give sort of a quick overview with some of the benefits of using narrowband TV white spaces, show you some results from range experiments, and then also give an overview for how a deployment would look like. So a lot of the benefits that of using narrowband TV white spaces includes long-range communication at low power, a much more simplified deployment, and also having many narrowband channels available for communication, which provides benefits on its own. So first off, I'm sure most of you already know that with TV white spaces, we can enable long-range communication. Since we're working with the UHF and VHF frequencies, signals can travel much further, even through dense crops and canopy. And I'm sure Andrew will probably be able to dive into this a little bit more just from his experiments or deployments later today. And so, for instance, when we were evaluating our system, we reached distances over 10 miles using these radios. And another benefit that I just mentioned is that we actually have multiple narrowband channels available. So since a single TV channel has a 6 megahertz bandwidth and we're using narrowband, the TV channel can be broken down into several subchannels, and that can be leveraged by the endpoint devices or clients to send more data rather than just using a single channel. So the capacity is increased in comparison to other mainstream IoT solutions. And another key benefit with this system is a simplified deployment. So since we can enable long-range communication, that means that we can support a very large coverage area. And our base station is capable of supporting tens of clients. So this means that if we want to cover, for instance, this area shown in the diagram, and that could span, several miles, we could just deploy a single gateway and then support hundreds of devices in this one area. So this lowers the deployment cost and also the system maintenance. If you were to compare this to other solutions, maybe like LoRa, for instance, in that same scenario, you would end up having to deploy multiple gateways just because of the limited range of the system. So aside from the hardware, another key component is the protocol that these radios follow. So we've designed and implemented a new communication protocol for the narrowband IoT operation in the TV white space spectrum, and this is, led by Tushar. So this includes developing a scheme to perform channel assignment, scheduling to support client communication, and of course a communication protocol to enable end-to-end communication. So I'm not really going to dive into the details of this, but if anyone has questions about it, we'd be happy to talk about it more. But anyways, each one of these components are crucial in enabling a reliable TV whitespace IoT network, and they address a lot of the key challenges when it comes to enabling such a system. For instance, things like selecting the best channel of operation for a large coverage area. If you think about deploying a deployment or deploying a system in any area, there could be a lot of TV channels available. And now if you break that channel into several sub-channels, those are a lot of channels that you have to go through and find the best one find the best channel of operation for that specific area. And that can be kind of tough when you have to go through all of those different options. So we have a scheme that helps solve that problem. Other things like performing client bootstrapping. So that's like adding a new client to the system, and also implementing a fallback mechanism. This is really important because, you know, as you deploy your system and the longer it stays on, sometimes some things that can happen are things like channel degradation. So maybe the channel that your client is operating on starts to become really noisy, or maybe that entire TV channel becomes unavailable. So we need a solution to sort of get the clients to transition over to another channel without the entire system going down. So that's just a little overview of a lot of the things that the protocol helps address. The next thing that I want to show is a couple of results for range performance. So the first result that I'm showing you is range experiments that we conducted in an urban setting, which was near Microsoft campus in Redmond. So for these particular results, we set our bandwidth to 32.5 kilohertz and our spreading factor to 12. So that would give you a data rate around 42 bits per second. And essentially what we do is we place the base station in one location and start and have it send packets, and then we move a client further and further away. And so this plot that you see on the left is RSSI with respect to distance. And what we see here is that you can actually receive packets as far as 11.5 miles in an urban setting. And we were actually able to improve this even more by using an LNA. So if you look at the map on the right, at 11.2 miles, the RSSI is only minus 84 dBm, which is really good in comparison to the plot at that point, which was around minus 37 dBm. So it's a huge performance increase. And the second plot is also a range experiment conducted on Andrew's farm. So Andrew did the same experiments, and he was actually able to get data as far as 14 miles in his location, which makes sense that the system would work much better in rural areas because there's less obstructions. But it also depends on you know, what frequency you're operating at, what the terrain is like, and also sort of what modulation parameters you decide to use. So the last thing that I want to go over, and then we can just open it up to questions, is just a deployment overview. So here's a diagram of, you know, what a deployment would look like at a very high level. There's two key hardware modules, the gateway and the client. So the gateway consists of a sub-edge device and a TV whitespace radio. So the sub-edge device is just an off-the-shelf device that could be a Raspberry Pi or an UP-board, which connects to the TV whitespace radio. And then the sub-edge sends all of the data to the cloud and also runs many of the key tasks that are part of the TV whitespace IoT protocol. And on the other end is the client, which is just another TV whitespace radio that can be connected to the sensor interface. So the sensor interface is usually something from a third party that you would want to integrate the radio with. And so you could get connect sensors to it that could get data over UART or I2C. And here's an example of what the gateway and client could look like. So this picture on the left is sort of all of the components that would make up a gateway. Typically we use a Raspberry Pi for the sub-edge, and you connect that to the TV whitespace radio just using a USB cable. And then just a few jumper wires that connect from the Raspberry Pi GPIO pins to the radio, and then, you know, an antenna, power adapter, so forth, Ethernet cable to connect to the internet source. And then on the right is an example of a sensor box that we developed ourselves for the client. So this is an example of how you could integrate the TV whitespace radio with a sensing system to get data. So we developed just a really, really simple sensor interface board where you can just connect a few analog sensors to get data. And we hooked it up to a little solar charge controller and a battery. So it's solar powered and it's weatherproof. I actually have this set up in my backyard, and it's been working really well. Like, haven't had any issues for over a month now. So that's really great. So that sort of concludes my overview of the radios for today and what we're working on. And I'm happy to answer any questions that you guys might have and have a discussion about this. Thanks.
Thanks, Zerina. If anybody has questions, feel free to unmute yourself, or if you got a question, you can throw it in the chat.
Is the sub-edge capable of handling multiple clients simultaneously? And if so, is that because of multiple channels or because of orthogonal codes?
Sorry, I didn't quite catch that. Can you say that again?
Sorry, I'm just wondering if the base station can handle multiple TV whitespace clients simultaneously? And if so, is that because there's multiple channels, or is it because you're using orthogonal coding?
Well, both. We can use multiple channels, but we also have a scheduling protocol that allows multiple clients to be communicating with the base station.
So if when say you're at that rate you talked about where you got 42 bits a second, that's shared across all the clients in time?
Yeah, so I'm not sure if I'm answering your question correctly, but basically, if we want to use 42 bits per second, then every client would have to use that same data rate. Essentially, it's sort of the scheme that we're following is similar to LoRa, which has the same limitation. Yeah, but the big difference is that, for instance, I was saying that there's multiple sub channels. So if maybe one client has a lot of data to send, it could send data on one channel, and then, based on our scheduling protocol, it could go to a different channel and send more data, if that makes sense.
Yeah. Okay. So the base station is capable of receiving on all of the subcarriers simultaneously. Yeah.
So yeah. Okay. Yeah. Okay.
So how many subcarriers are there across that a band?
Tushar, do you know how many channels we break it up into?
So it's per TV channel, it's 55 subcarriers. So now it depends on the location, how many TV channels you have available in your area. But per TV channel, we have 55 subcarriers.
Okay, thank you very much. Appreciate it.
So one question was, what is the power that the IoT radio needs, watts or current? So the last time we measured current consumption, which is a little outdated, the transmit is 122 milliamps and the receive is 12 milliamps. So it's pretty low. I can tell you, as an example, which for like the sensor box that we built, which is extreme, like overkill, we're just using a 6-volt battery that maybe has like 10 amp hours, if that helps. So it's pretty low. Let's see, one other question is, what kind of resources do you need into the FarmBeats integration? Can you clarify a little bit? Or do you mean just Like what hardware components or?
Thank you, Zerina. So your presentation was amazing. Thank you so much. So my question regarding with the FarmBeats integration, I know that it's possible to integrate the IoT radios with the Azure account. We need to create the IoT hub and set up the device in the IoT system that Azure has. But I have the question regarding with what is the, how is working the integration in between IoT hub and the FarmBeats integration? Because FarmBeats is data aggregation, so we need to put there all devices that we have, identify the type of the information that we are sending. So this is my question is regarding with that. What is the things that we need to set up in the FarmBeats integration to work with the IoT radios?
So the biggest thing is setting up your sub-edge. So we have an app that runs on the sub-edge that sort of works as like the middleman between getting your data from the clients over into Azure and then displayed and part of like the FarmBeats IoT dashboard. So that's something that we developed that you would just have to install on the sub-edge and run. So as part of your like Azure subscription and you're setting up IoT Hub and all that stuff, once that's done, once you configure your sub-edge with our app, it should all sort of just seamlessly integrate together. Yeah, I hope that answers your question.
Yes, Zerina, thank you so much.
Cool.
Looks like Andrew almost had a question. Did we get that one answered?
Is that 12 milliamp arc continuous or average? I'd say average. I mean, the radios go into sleep mode when they're not transmitting or receiving. So, I mean, I would really take those numbers with a grain of salt because we have to, since we've developed this new version, we haven't finished our current consumption measurements. So I can get back to everyone on that. But the last time we measured it was 12 milliamps, yeah, average. Probably even less than that, I think.
All right, any other questions for Zerina? Okay, thanks very much. We'll make like I said, the video and Zerina's presentation. If you want to share it, I can make that available on our community site too.
Yeah, sounds great.
Okay, perfect, thank you. All right, next we have Andrew Nelson. Andrew, I gave just a brief introduction. I'm not 100% sure what you'll be covering today, but I think you were going to talk a little bit about TV whitespace and maybe some of the other FarmBeats work that you're doing.
Yeah, so I was going to go over a little bit on the truck AI. I should have synced with Zerina because I had the exact same chart for the TV whitespace for the distance. But I do have an elevation chart that she didn't show, so which I was going to chat about. So I just wanted to go over those, and then starting this next week, I am actually rolling out a lot more TV whitespace sensor boxes. So I was going to kind of give an overview at the next meeting on how that went, how my base station is set up, so that way everyone can kind of see how we rolled it out here and, you know, use that as a guide if needed. So, and then, yeah, I'll share my screen. It's a little tangential to FarmBeats, so I'll keep it a little bit shorter with the truck AI, but it does definitely integrate with what all the different FarmBeats components I'm using around the farm. Operations is obviously a big part of my farm, so using something that can process on the edge or in the cloud is very beneficial. So I will share my presentation if it lets me, hopefully. I was going to demo, but then I was crashing Teams with my GPU when doing that. So that's why I was on a little later today. So I apologize for that. But I'll try to get this at least enough so that way gives everyone an idea. And I do plan on posting my code out to GitHub. I forked a repository from Microsoft Research, and I'll be doing some updates to that with the Truck AI. All right. Can everyone see my screen?
Yes, we can.
Yeah, great. Okay. So, like I said, with Truck AI, I'll go over that quickly first. And it's something that I've been looking and working on for a while and integrating it with my FarmBeats instance. So that way I can save my, I actually use the FarmBeats information, the location, weather information for when I harvest the crop and store it. So that way I know what environmental conditions I had at the field at the time of harvest, which is helpful for me when figuring out, you know, when I need to turn on my fans, cool down my crop, and how long I can expect storage to last without getting bugs or spoilage or anything like that. It's a pretty simple diagram for how I have it set up. I have a camera outside that points at my truck, and I have a camera inside that points at my scale. You can also get scales that are connected via Bluetooth. The problem is those cost so much more. I decided I'd rather just buy a cheaper camera and just do, you know, some simple OCR and grab the scale weight off of the scale. And the other nice thing is I can move this between scales easily. So we have a couple locations where we have grain storage. So I'm kind of making this system so I can move it to the different locations, and that way there's less human error in it, and I also have even better record keeping. So what I have right now is a link with Wi-Fi to my edge device. My edge device is just my office computer right now. For next year, I'm actually going to be switching it to NVIDIA Jetson, just because there are many examples of building on it. The Microsoft Research Rocket that I used can be deployed onto it, and they're relatively cheap. And that way the device and the cameras can all sit at the same location, so I can easily move it around. And then so at my shop, it'll be connected with Wi-Fi. At the other locations, all connected up with my TV Whitespace link. As I said, the camera setup is pretty easy. I just have my, these are webcams, but I can even, with the Jetson, I can just connect one to the board, which is nice too, to point straight at my trucks as they come in. For right now, I do look at license plates, but I have a college student who's taking a gap year who is going to be helping me train my model. So it'll identify my different trucks and different types of trucks better, and assign them kind of somewhat random, but you know, IDs towards every truck. I used Microsoft Rocket. The link is here for getting it. It's on GitHub. The nice thing about it is you can do edge processing and cloud processing. So as normal in rural America, my internet's not the greatest. So I can do most of my edge processing. And if the confidence isn't high enough in what it sees, it can send it up to the cloud to use more heavy-duty processing. And the other benefit there is I don't have to pay for all the cloud processing when it's, you know, easier AI processing that can be done on the edge. And if there happens to be an internet outage, everything can still work because it's still processing on the edge. And I will do a very quick demo. So my demo, I can't do the full one, unfortunately, since my graphics cards plus PowerPoint plus Teams get angry at each other and cause my computer to reboot. But I'll do part of it, where this is just I saved some live feeds from harvest. As you can tell, it was super smoky that day from the forest fires that we had nearby at the end of harvest. But what this is doing is it will detect when the truck comes and stops, and then that image I can then use for further processing. So when the truck pulls up and stops, you'll see a very quick flash on the left side that will count that truck, which it did. I can actually scroll up. So you can see that there's a truck from the left entrance. And then it saves off that image over here that I can do further processing on. So that's kind of how I kept the flow going. With Rocket Code, it already supports RSTP, so that's pretty handy where I can already connect up to the webcam feed and just pull the information. It also means that if I want, I can leave my edge device at my office at home, and as long as I have a TV whitespace link to our other bins, I can, you know, still process these truckloads automatically without having to move as much equipment everywhere. So I kind of skipped my order a little bit on demo. So that was just a quick overview of the truck AI. I'll probably do a little bit more. We're showing the integration that I do to FarmBeats later. I couldn't take as many pictures. I am in quarantine right now due to my kids' daycare, so that's always fun happening right before a presentation. And then I want to go over the TV whitespace connectivity experiment. This is the same thing Zerina showed, so I'm not going to dwell on it. I do just want to point out one item here, which is the TICO location, which is nearly 12 miles. And you'll see that still has a decent RSSI connectivity for the TV whitespace. But the best part is where I place the tower does not have line of sight to that location, which is, you know, 12 miles away, and I was still able to get connectivity. So this is one of the spots for my TV whitespace sensors. It's a really difficult spot to be able to get, you know, information from. So having this sensor here, being able to actually connect to it with TV whitespace is going to be very beneficial to our farm. It's one of our fields that is also in a different microclimate. As you can see with the elevation on the right is at the base of a mountain. And so the microclimate there is much more different than the rest of my farm, which lives closer in this area, in this kind of valley. So being able to get the information from there without having to beg and plead neighbors of our fields is very beneficial for me in the upcoming years. And that's about all I have for my quick demo for the day. Are there any questions around either truck AI or the planned rollout with the additional TV whitespace that I'm doing on my farm? The roar is very loud.
Seeing what you're doing with the tracks, that's really cool. I know you'd talked about that for a while, and we were talking about that problem earlier in the year, and just seeing it working like that, that's very cool.
Yeah, and the best thing is I'm actually wanting to use the same sort of information actually with Paula's stress cam. So the same sort of where I can do on the edge processing and also send it up to the cloud. So that one I will be feeding it from her stress cam that's connected over Wi-Fi. But that's, so what I'll be doing this year is detecting rust with that. And if we get it working, which hopefully we will over TV whitespace, I could have automatic detection across the across my farm, which would mean that I would see rust, you know, potentially 5 days earlier than I usually do. I mean, I go over all of our fields at least weekly, but that's like a whole day job. And so being able to access that information and have alert to it, you know, within a day, especially some of the fields that are harder to reach, they're far out on a dirt road, takes you, you know, just 10 minutes to drive on the dirt road alone. This will definitely help a lot.
Are you using drone images for that?
So that's actually Paula's stress cam. It's her camera that she has pointed to the crop. And I'm using it locally here over Wi-Fi, but we're hopefully going to get it some more connectivity on it. So locally, I'm using it to monitor my cover crop and winter wheat that I have near my homestead here, but I'm very excited to get it further out.
It's like there's a question. What is a stress cast? I don't know if it's Paula or you, but
I think that's Paula.
Okay. I don't remember if you saw my presentation. We talk about, okay, I'm working in the NCSU in North Carolina State University. So we have this big project with the stress cam. It's a tiny, I'm not in the Arctic. I'm so cold right now. So, and the stress cam is a tiny camera. It's a low cost and smart. Thank you, Andrew. So, and we are working with the stress cam in a different way. So one way is just connect through the Wi-Fi. We are using a Raspberry Pi Zero W that also has the capability to connect with the Wi-Fi system. The problem that we have right now with this board is that we connect to the 2.4 gigahertz band. So I think this is the problem that Andrew has now. So, and we are working with the FarmBeats integration, with the cellular connection, and also right now we are working with the TV whitespaces. So we have right now the support from Zerina and all team to put the IoT radios in the stress cam. So the principal thing with the stress cam is low cost, smart, and IoT system.
I just read the comment from you.
I'm bundled up in my office too. I've got my scarf and my blanket. It's so cold. Not as cold as I'm sure it is there, but we still get a little chilly here. Does anyone have any other questions for Andrew while we have him on the line today? I know everybody always wants to hear about what he's doing with FarmBeats and the work on his farm there. Anybody have any questions for him about the presentation or just other work in general?
Andrew, this is Elizabeth. I know this is probably the time of year when I hope you have a chance to reflect and go back, maybe look at data and think about what you're going to do differently next year. I don't know if you've already thought about like what are, some of the, the things you want to take on next year or the new kind of FarmBeats related applications that are on your priority list, but do you have any feedback?
Yeah, so, working with the stress cam is actually one of them because being able to gain that insight quicker will definitely help me a lot. And then a continuation of a few different items I started last year and a few new ones. So the continuation on last year is I am actually having one of my employees get his drone license, so he can actually go do drone flights for me as well, because I'm going to be doing more spot spraying, and so I'll use the edge processing. He'll actually be the one using the edge processing, so that'll be scary because it's not just me, the computer scientist, doing it. It's going to be one of my employees, but so he will be doing a lot of the flights, getting the stitches ready, and then I'll be using that for my precision spraying with my drone sprayer. So utilizing my drone sprayer more for next year is definitely one of my priorities. The other item is with carbon, figuring out how we can more effectively sequester carbon with information from FarmBeats, and still be able to manage our farms well. So still be able to manage weeds and pests well in our farm, and also sequester as much carbon as possible. So that's another item that I'm working with through FarmBeats for the following year, and we're running scenarios through models and stuff like that to see what they're going to look like. Last year, definitely having the sensors spaced out was very helpful. The drone information is invaluable to me. And so I just kind of plan on expanding those for the next year. And Zerina told me that she's giving me 20 more TV whitespace IoT devices that will spread out. So
That's cool.
That'll be very exciting. We'll have one about every 3/4 of a mile, no matter where you stand on our farm.
Impressive. Very impressive. Cool. Well, thanks.
Yeah, it's always interesting too to hear the effect that the FarmBeats technology has made on your farm. I know you've talked in the past about the cost savings and the time savings, and the technology is always very cool to hear about, but I think it's really interesting too to hear the direct impact it's made on the work you're doing on your actual working farm. So I think that's very cool.
Yeah, I'm trying to work with more researchers to make it a little more than just me collating the data.
Yeah. You're just one man. There's only so much time.
Yeah.
Any other questions for Andrew? Okay. Well, that's all the presentations we had for this month. I really appreciate everyone tuning in and listening and having all the great questions for both Zerina and for Andrew. We don't have any additional meetings on the calendar yet for our user community forum, and we'll be putting those out at least for the first quarter of next year. And I'd like to get a little bit of feedback from the group about dates and times, days of the week that work better. So rather than emailing everyone individually, what I'll do is I'll put a survey up on our team site. And if you have a moment, if you could just go out and respond to let me know what days of the week work best, what times work best, so we can put the meetings at a time that's most convenient for everyone. If there's topics that you're interested in or subjects that you would like to see us talk about on the community meeting, we're certainly open to that too. We want to make sure you're getting the information that you need and we're sharing the right level of detail. And if you haven't already, take a look at some of the resources we have, the YouTube channel and the GitHub site, and we will post everything out in the Teams channel, and I'll provide a link to the recording of this meeting later today. So big thank you to everybody, and I hope your holidays are stress-free and you can get a good break. And 2021 hopefully will be a much easier year than this one has been for all of us.
Thanks, Stacy, and thanks to everyone for joining us. Happy holidays. We'll see you again in the new year.